All right, so we're looking at homework problem 27 from 2.1. The function that was given to us is f of x equals 3 parentheses x plus 2 squared plus 1. We want to describe the transformation of the graph and then identify the vertex. So if we look at this here going left to right, well, the first thing we have is a 3 outside the parentheses. Well, that'll be a vertical stretch of 3. The 2 inside the parentheses would be left 2 and then up 1. Now, what would the vertex be? Negative 2 and 1. And that's it. Any other questions? Okay. Exploring the focus and directrix. Previously, you learned that a graph of a quadratic function is a parabola that opens up or down. A parabola can also be defined as the set of all points x comma y in a plane that are equal distance from a fixed point called a focus, or called the focus, and a fixed line called the directrix. Focus and directrix. And we do have set equations for this. Now, the equations that I have listed out are going to be a little different than what you have on the paper. Now, we're going to have two main equations. Y is equal to 1 over 4p, parentheses, x minus h squared plus k, where the focus is h comma k plus p, and the directrix, make sure I'm spelling this right, R-E-D-I-R-T-T-R-I-X, is y is equal to k minus p. And for either one of these here, the vertex is still h comma k. Well, be good to write the axis of symmetry. Axis of symmetry is x is equal to h. Focus h plus p comma k. Now, I decided to do this a little differently this year. Because I've still not found the most effective way of teaching this yet. So we're trying something new this year. Now, I know that yours does not have all this information there. Yes? And that's the way I taught it last year, is with those forms. But I want to go on and give you the full equation. I want to go on and give you the full equation because this full equation will work with those setups for that we were going to cover today just fine. And this will also work when the vertex is h comma k. Because all the problems we're going to look at today, the vertex is going to be 0, 0. The vertex is going to be the point 0, 0. So if we took, new page, y equals 1 over 4p, you don't have to write this down, this equation here, vertex is at 0, 0. So h and k are both 0, yes? So we get y is equal to 1 over 4p, parentheses, x minus 0 squared plus 0. What's x minus 0? It's just x, because if we subtract 0 or add 0, it doesn't really add or subtract anything from it. So we're just left with what? X squared. Do I even need the plus 0? So we get this here, yes? Isn't that the equation that y'all have down? Yeah, that's what it works. But I'm hoping that instead of working with that one there and then moving to the one with the vertex values, if we just start here, this will make a little more sense. Now again, we're not going to graph these here, but we're going to go on and look at the first equation. Now when we look at this here, we have a negative 4x and y squared, yes? Now when we look at our equations that we're given, we have two. We have y equals 1 over 4p, parentheses, x minus h squared, plus k. Or we have x is equal to 1 over 4p, parentheses, y minus k squared plus h. What variable is squared? Y. Y is squared. So most likely, the equation that would have the y squared is the one we're going to work with. Now, I will say this, the vertex is going to be at the origin for two reasons. One, do we have any y's that are not to the second power? Do we have any numbers in there that do not have a variable with them? No. So the vertex will be 0, 0. And what I mean by that is if we had negative 4x equals y squared plus 2y plus 1, then we're going to have something. Because that y minus k squared, if it's multiplied out, all the way out and distributed out, then we'll have something like this here. We're not going to cover too much of putting that back together. We're going to focus on a lot of the basic forms. So when we look at this here, negative 4x equals y squared. We're looking at this one here. Because this one here is going to have the y squared connected to it, yes? Okay. That is the form we have. What's one of the main differences that this has besides, what's x? X is x by itself. No, our actual starting equation is negative 4x equals y squared, yes? We need to get the x by itself. That's going to be our first main step. So negative 4x equals y squared. Almost. We're going to divide both sides by negative 4. Because negative 4 divided by negative 4 would be 1. So we're just left with x is equal to. So we would have y squared over negative 4. I'm wanting, and it's going to make it easier because we'll move that y squared over. 1 over negative 4 equals y squared. Any questions on this so far? Now we know that the vertex is 0, 0. And a lot of these, I will tell you outright what the vertex is if it is 0, 0. And a lot of the problems will tell you the vertex is 0, 0. Solve it from here. So we know that h and k for this problem are both going to be 0. And we did get it into a form we like. And the reason I know it's in a form we like because both of the standard equation, the term that's not squared, y and x are by themselves. Yes? So when I look at this here, down here, is x by itself? Yes. Okay. Now the rest of the equation, well, we have 1 over 4p, 1 over 4p times the x or y that is being squared, either in parentheses or without. Do we have a number multiplied by y squared? Where y squared is not really in the numerator, but it is connecting to it. We have that. And then everything else falls in place. So we have it in the way that we want, because that's the way I want this set up. Any questions on how we got this set up or got to this step? Okay. So let's see what it's wanting. It's wanting focus, directrix, and axis of symmetry. Focus. Well, the focus for this equation, x equals, is h plus p, comma, k. Directrix is, I don't need a parentheses, y equals h minus p. And the axis of symmetry is y equals, okay, that should be an x. X equals h minus p. Any questions on this here so far? Okay. Do I know what h and k are? What's the value of h? What's the value of k? 0. Okay, so I could plug those in and get that, yes? So the axis of symmetry is going to be y equals 0, yes? The directrix is going to be x is equal to 0 minus p. What's the value of p? Do we know that yet? So, well, we haven't found it yet, but that's what we're going to find next. That is what we're going to find next. In the general equation, where does p show up? In the 1 over 4p, yes? And it's always, in both equations, it's the term being multiplied by y squared or the y minus k squared here, yes? The y squared or that squared term in parentheses. That's where p is located, yes? It's right here. So where is that in the equation? Right here, yes? So this here is what's matching up with 1 over 4p. So right here is where the p is located, yes? It's tucked inside there. So really, the negative 1/4 is where the 1 over 4p is located, yes? Because, I mean, that's where they match up. That's where it is, isn't it? So what we can say is that 1 over 4p is equal to because where is it at? Where does it match up with? Well, the 1 over 4p is where the negative 1 over 4 is. That is its location, yes? And this is part of the reason why we get it set up in this way, because now I can match those two up and solve for the value p. Well, p is in the denominator, yes? So to get it out of the denominator, I'm going to multiply both sides by 4p. This 4p and 4p will cancel, leaving us with 1. Negative. Well, what happens with the 4 and 4 here? Because that would give us what? 4p over 4? Because when we multiply, we always multiply by the numerator. Well, it would be negative p, yes? So how could I get this positive? Well, we would just divide by negative 1 and say that p is equal to negative 1. Questions on this here? Mm-hmm. Yes. Uh-huh. Mm-hmm. Any other questions? So we know what the value p is, yes? So I can come back up here and plug it in, because this here, the directrix is h minus p, so 0 minus negative 1. And the focus is 0 plus negative 1. So our focus for this problem, 0 plus negative 1 is negative 1, 0. Questions on this here? Yeah, 0 plus 1. The directrix is going to be x is equal to, well, we have h minus negative 1, which would be plus. So it's x is equal to 1. And the axis of symmetry is y is equal to 0. And that's it. Questions on this here? Okay, so we look back up at the top. It asks for the focus, directrix, and axis of symmetry. Focus, directrix, and axis of symmetry. We have all 3. And that's it. Questions on this here? Identify the focus, directrix, and axis of symmetry. Well, here the vertex is going to be 0, 0. And really, the main ways is, one, everything we're covering today, the vertex will be 0, 0. But also, I do have x by itself, yes? We have x to the first power. We have y squared, yes? Do I have any other variables that have, or do I have any other y's that are to the first power? No. We don't have any other numbers added or subtracted. So the vertex is going to be 0, 0. Because if, again, like I said earlier, if we actually had, say, plus 1, y plus 1, it moved it 1 down, actually had a movement from the vertex, something like saying, well, it'd be good to write, having y plus 1 squared was part of the equation, and they didn't have the parentheses, it would really show up as this. We would have that term, because essentially they're taking that y plus 1 squared and distributing it out, if we had it all the way written out. But because the vertex is 0, 0, we're just going to have our y squared and we're going to have our x. Or we'll have our x squared and our y. We won't have more than that. But we do see that the y term is squared, yes? So that means the general equation is going to be our x is equal to 1 over 4p times y minus k squared plus h. Now our vertex is the point 0, 0, yes? Now if I plug that into here, we would say x is equal to 1 over 4p times y minus 0 squared plus 0, yes? 1 over 4p is not going to change. What's y minus 0? And it is squared, yes? So we'd have y squared. Do I need the plus 0 at the end? No. So we have x equals 1 over 4p y squared. Understand how we get to this form here? Now, I'm going to move all this over. Try to. Nope, apparently not. Try it again. There we go. Okay. All right. There's the answer. And we'll explain how we get there, because it doesn't have all of it. Now the focus is what? We can write it above it, h plus p comma k, yes? Directrix is our x, y is equal to k minus p. And the axis of symmetry is x equals, no, do this every time. Yep, I did have that right. It was x equals, and this is y equals h minus t. So again, having these handy, and especially I would write them on your notes, not on your notes, on your review sheet when you go to take the test, to have these out. Because it's very easy to switch these up if you're not paying attention to it. Now axis symmetry is x, y is equal to k. Well, do I know what h is already? 0, k is, h is, k is 0. So that's the axis of symmetry is y is equal to 0. That's one's done. But what are we missing in all of these here? The p-value, yes? Well, if we get this into our x equals form, the 1 over 4p, whatever number is being multiplied in front of y, should match up with our 1 over 4p. Because those are going to be in the same plot, so the p should be in that number, in that fraction, in that location. So that means if I can take negative 2x equals y squared, and get it in the form x equals 1 over 4p y squared, then I can find the value of p by setting those equal. So what can we do to get x by itself? Divide both sides by negative 2. Is negative 2 divided by negative 2 will simplify to 1. Minus x is equal to Well, negative 1/2 y squared. Because I could have it as y squared over negative 2. But again, that's the same if we just move it out to the front. Because we're also multiplying by negative 1/2. Any questions on this here? So this negative 1/2 is matching up with our 1 over 4p. Yes? Those are the same. They're in the same location. So the value of p is trapped somewhere inside the negative 1/2. So to find it, what we can do is set the negative 1/2 equal to 1 over 4p. Now what can we do to both sides? Times both sides by 4p. And the nice thing is that the 4p and 4p over here will simplify to 1. Over here, we're going to have negative 4p divided by 2. Negative 4 divided by negative 2, or negative 4 divided by 2 is negative 2p is equal to, is p by itself? What do we need to do? Divide both sides by negative 2. And we get that p is equal to negative 1/2. Any questions on how we found the value of p? So up here we have 0 plus negative 1/2. Well, 0 plus negative 1/2 is? Here we have 0 minus negative 1/2. Well, negative and negative make a, which is just going to be and that's it. The focus would be negative 1/2 comma 0. The directrix is going to be x is equal to 1/2. And the axis of symmetry, y equals 0. Questions on this here? Y is the term by itself, yes? So that means we're looking at y is equal to 1 over 4p, parentheses, x minus h squared plus k. This is the equation we have. Now we already know that what? The vertex is 0, 0. And we saw in the last one, really, the minus h and minus k are going to go away, yes? Because they are 0, 0. So what are we really left with? 1 over times x squared. Which is nice for us because the focus for this here is h comma k plus t, yes? Well, the h value is, and here we're going to have 0 plus p, yes? We don't know what p is, so I'm going to leave it there. Directrix is our y is equal to k, well k is 0, yes? Minus p. Do we know what p is yet? No, so we can leave that there. Axis of symmetry. X is equal to 0. Because x is equal to h, so here it's just equal to 0. So what's the only thing we're missing? P, yes? Because if we have p, we can finish this out. So our original equation is y by itself. Yeah. They already have it set up for us. So what is our 1 over 4p matching up with? It's matching up with the 0.5. Does the 4p and 4p will? Fine. So we're left with 1 is equal to. What is 0.5 times 4p? What do we do next? So the focus will be 0, 1/2, because 0 plus 1/2 is going to be 1/2, so we have 0, 1/2. Now the directrix would be 0 minus 1/2, so it'd be negative 1/2. And our axis of symmetry is x is equal to 0. Questions on this here? Okay. Now again, the vertex is 0, 0. Now the x is squared, so we're looking at y equals, well, it'd be nice if I write, y equals 1 over 4p, parentheses, x minus h squared plus k. Are not really here because the vertex is 0, 0. The value of h and k are both 0. So since we don't have that, really we're looking at y is equal to 1 over p x. Now we need to just get this equation in this form. Is there anything that we do need to do? So we start out with negative y equals x squared. So what can I do to make the y positive? Divide by negative 1. And negative y divided by negative 1 would be positive y equals. So we have the focus, directrix, and the directrix would be y equals, and our axis of symmetry is x is equal to. Now our focus for this here is h comma k plus p, but we know that h is and k is 0 plus whatever p is. Our directrix will be 0 minus p, and our axis of symmetry is just 0. Yes? So we just need to find the value of p. So in this one here, what is our 1 over 4p equal to? What's in its place? I'm just glad I paused that. So because there is a number in front of there, it's just not written, it is negative 1. So it's going to be equal to negative 1. Even if there was no negative, it was just y equals x squared. The number in front of x squared is. So 1 would be equal to our 1 over 4p. It is possible for that to happen. Now our first step in finding the value of p is going to be 2. Both sides by. So net 1 is equal to negative 4p. Here we would divide by negative 4, telling us that p is equal to negative 1/4. Because when we think about this here, negative 1/4, because if it's put in the denominator here, well, what is 4 times 1/4? 4 times 1/4. 1, yes? So our 1 over 4p, in the denominator we have that 4 times 1/4, which would give us 1. 1 divided by 1 is 1, so it just becomes negative 1. So whenever we have just a 1 there, it means that the p was simplified out, whatever the value p simplified out with that 4, giving us 1. So we can come back and plug it in. 0 plus negative 1/4 is just negative 1. 0 minus negative 1/4, well, the negative and negative make a, so it's just 1/4. And that's our answers. Questions on this here? How do we feel about this so far? Pretty good? This is part of the reason why I consider this one of the harder things to teach, because it is pretty simple at its foundation. Yes? We get it set up, we match it up, we match it up, we're done. We get it set up, we match it, we're done. And again, as long as we get these steps down, we're good. And this is one of the ones that every year that I've taught here, this has been one of the hard ones. Okay? So again, as long as we keep these steps, we're good. So, identify the focus, directrix, and axis of symmetry of the parabola of the equation. So the y is squared, yes? So which equation has y squared? Dx equals 1 over 4p parentheses y minus k squared plus h. But again, because the vertex is 0, 0, we're mainly focused on this form here. Okay. The value of h is, the value of k is, the value of p is, we don't know, so let's find it. So do I need to manipulate this equation at all? We need the x by itself, yes? So the first thing we can do is divide both sides by 6. Because 6x divided by 6 would give us just x. It is equal to, we can call this 1/6 y squared. Because really we could say y squared over 6 and then move it over to the side and have the same thing, or we can just go straight to this here. And this helps us because, again, the 1/6 is taking the place of 1 over 4p. That's where these line up, yes? So really I can say that 1 over 4p is equal to 1 over 6. So Chloe, I would agree. I mean, we could, because the numerators are both 1, we could technically, if we wanted to, set this up as 4p equals 6. Because the numerators are both 1, so we can set the denominators equal to each other. But the reason I would do this here is because if we didn't have 1/6, if we had 7/6, then we're going to have to do it this way. So if it's 1 and 1, it works out 4p equals 6. That would work. Because 4p equals 6, we would divide it by 4 and get 6 over 4. So let's see what happens. Here, so again, our first step was to multiply both sides by 4p, yes? Well, 4p and 4p will cancel out. Equals 4p divided by 6. Now, the next step we can do is we need to get p by itself, yes? So I could divide both sides, or I can multiply both sides. Because what I can multiply both sides by is 6/4. Because that would give us 6/6, yes? Which is? And then the 4p and the 4 on bottom would become 4/4, which is? Six and 6 would cancel, 4 and 4 would cancel, which would give me p by itself is equal to what? 6/4, yes? Well, 6/4 will reduce to what? Yes, so 3/2, because 6 and 4 both have a common factor of 2 that will reduce out. So this here, it would have worked that we could have set 6 is equal to 4p divided by 4 and gotten 3/2. But with the 7/6, it wouldn't have worked out as nicely. And one of the big things I would say, especially 4/6, we have this fraction. Let's finish this up because we only have 2 steps left. Because we said 3/2, so p is 3/2, yes? Focus would be r o plus p, so it'd be 3/2, comma. The directrix would be x is equal to 3/2, and our axis of symmetry is y is equal to 0. Okay, so